Today's topic is weldment. In this image you can see the construction of a dust collector of a refinery plant, and almost all the part has been designed in SolidWorks and assembled, and they are all kept in one structural frame called as weldment structures. And the challenge for designing the weldment structure is the details. What we need is the structural members, how many is required for constructing the entire framework, and also the length required for each structural member. But this cannot be derived once you do the weldment structure in part modeling. But this is possible once again in SolidWorks by using weldment design. What actually we are doing in weldment design? One, you are inserting the structural members on a 2D or 3D sketch. Based on that, you are constructing the additional structural members called as the square beam or I section beam or C frame. It's according to the requirement. And based on this, finally the output what we need is the part list. In simple terms, we can say how many structural members is required to complete this entire fabrication, plus what is the length for each structural member. These are the details you can get from weldment design. And in this area, let's see the advantages we have with weldment. First point, weldment design, weldment functionality enables you to design a weldment structure as a single multi-body part. This is the output you will get when you design any structural frame. It will be a single part, but you can see multi-body part will be there inside. And you can use both 2D and 3D sketches to define the entire structure, and you can insert the structural members on the 2D or 3D sketches. And later, to add strength to the structural members, we use rib, or we can say gussets. And to close the open ends of the structural members, we can insert end caps. So these features, these commands are specifically given in SolidWorks for designing the weldment structures. And once you complete the whole command or whole design, you can have the cut list icon shown in the SolidWorks feature manager tree. You can right click and you can say update, and later you go to the SolidWorks drawing environment. You can place the isometric view or front view, and then if you furnish the details of the weldment cut list from the insert menu, you'll be able to get the exact details required for the entire structural member. Let's see how we can do this in SolidWorks. This is the first example we are going to see. A stand used in heavy engineering. This we are going to design using structural members commands. Let's see how we can do this. Now let us see how we can insert structural members on the 2D or 3D sketches drawn in SolidWorks environment, and the different options available at the structural members dialog box we call as property manager. Now I'll remove this structural member, and I have the 3D sketches done already. If you need, you can draw by using sketch 3D sketch. As you know, we had seen this in sketching environment. Using 3D sketch, you can draw a sketch, and later you can use tab key to flip the direction, and you can use once again line command to create multiple line segments. Okay, this is one simple example of creating 3D sketch. Definitely you will be knowing it. Now similarly, I created 3 line segment, okay, which is of having length as shown here. Now I would like to insert the structural members on this 3D sketch. So there is no constraint like structural members should be insert on only 2D or 3D. It can be on both the ways. Let's see how we can do this. go to weldment. Here we have structural member, and from here you have standard and ANSYS. I will use standard, and I will say ISO, and once again I will use square tube, and size I need 20 into 20 into 2. This is the predefined weldment type and predefined size. You can select this to insert this square tube, and now let's see this structural member inserted here, but it's very small. Now what I will do, I'll change this to 80 into 5. Okay, now it's very small, but as per my requirement I need different section to be, that is different structural member of different size should be on this 3D path. How can I do this? I had created already the user defined sketches, and I had stored in the standards. Now let's see how we can retry this. Go to WORKBENCH, once again structural member. From here I will choose ISO, and from here I will choose SB beam, and here you can see as a predefined you will have only these 3 structural sizes, structural member of sizes. Now I'm going to use this I508 into 508, and here I need to attach, but this should be exactly attached on this endpoint. So what I will do, I'll go and say it is right now aligned at this endpoint, but we need to align on this endpoint. I'll go to locate profile, select this end. Now you can see the attachment of structural member, and one more beam has to be attached. But if I attach that beam, then these 2 beam will have the same orientation and also the same location point. What I will do, I will go to new group, and here I will say once again, here I need to attach, and the point is we can use locate profile, and I need to locate here. You can use locate profile, and also if you want to rotate this, you can enter the values here to position the structural member. And apart from, similarly you can use mirror profile, and you can say any reference accordingly. You will get this orientation for this member. And we have one more advantage, like wait, I will first position this. Once again I will remove this line segment, and new group, this is my profile, locate profile, this is the point where I want to locate, this is the point where I want to locate. Once I complete this, now let's go to the next new group, this one, and once again I will go and say locate profile using this endpoint, new group. Now we are in the selection of this 4th profile, select this. Similarly go to locate profile, select this endpoint. So once you completed, you can right click to accept this structural member attached with 3D profile. And now let's see how the additional structural members can be inserted and how it can be trimmed. Now we are going to see the additional structural members inserted over this members. I'll go and create a 3D sketch. On this face I would like to draw from here to this face. I'll select this and I will say along X it should be parallel, and dimension from here to this line segment it is 1400, and click OK. Now I need to insert one more structural member. Here I will choose same SB beam, and apart from that, as you know, if you go to ANSYS inch, you will have different type of types, that is angle, iron, C channel, and once again you will get sizes according to that. Now I will choose ISO. Here I will say SB beam, structural beam. Here I would like to say I508 into 355. Then select this first profile, and now I need to once again position this, I need to position once again this thing. What I will do here, go and say position exactly, locate profile using this one, and now it has to be rotated. I'll make it as 90 degree and okay, 270. Now you can see it is attached here. Once again, go to locate profile. I will say from here it should attach. Now you'll be able to see the structural member is attached between these two members. I'll click OK. Now we had assembled this, but here we don't require this additional projections here. How I can remove this material? Do we have any indirect method? Not required. You can go to trim extend. Here you select the first body and one more second body to be trimmed. Sorry, I will remove this. Bodies to trim is this, and trimming boundary is these two. Now you will be able to see discard and which is to keep. I'll click OK. So which finishing you need? Simple cut between bodies, or it should be having a coped cut between profiles. Additionally, if required, you can also add weld gap. I'll click OK here, and in this trim and extend you can see once again we have end meter and then end butt 2 and end corner, end trim. Let's see this example in other exercise. Now you can see how these two structural members is trimmed using trim and extend. This command will act both ways, that is, you can use either for trim and also for extend. I need to add one more on this side. I'll go to sketch, line. From here I will choose the first point and it should be on this face. Once I've drawn this, once again I will say this should be parallel, it has long Z. Click OK. Now insert structural member. Here the same size I would like to locate on this one, but here it should be rotated about 360 degree, and locate profile should be exactly on this one, and click OK. Now we inserted the second structural member, but still you can see it is not trimmed properly. I'll go to trim, bodies to trim, this is the body to trim, and boundaries is these two boundaries. And now as usual you can select here done. Now you will be able to see exactly structural members are trimmed and it is properly placed. Now I don't require this 3D sketches. I will hide it for the better visualization purpose. Now do I need to do the same thing on the other side to get the same structural member? Not required. Go to mirror. In the mirror we can use which phase you want to, which plane you want to do mirror, which plane will be used as a mirror for structural member, and here you can choose bodies to mirror. Select this body, click OK. Once again mirror command, the plane I will choose right plane, and here bodies to choose, this is my body. Now you can see as simple as possible we created this stand for heavy engineering. This is not fully designed, this is a partially completed structural assembly. Now we need to understand one more point, that is when you do trim or extend you have different treatment methods. Let's see how we can understand in SolidWorks. I'll open my predefined profile. Here we are going to understand this one. Go to element, structural member. My structure, first structure is 100 to 180, this is one, and next one more new group, or I will choose once again the second line segment, and third, here you can see the different corners, end meter, end butt 1 and then end butt 2. Which type of finishing you need at the corners? I'll choose end meter, and if required you can use gap and merge meter trimmed bodies. I don't require anything. I'll click OK here, and apart from this you can see merge arc segment bodies. If I use merge arc segment bodies, then this arc segment bodies will be one single body. I'll click OK now, and we have two groups. I'll click OK here. Now you can see 1, 2. Even though this and this are two separate line segments, these two are merged because we given merge arc segments. And once I decided I'm going to create the structural member, but at the end I think this end is not preferable. You can go and choose bodies to trim, and you can say which type of end you need. But here no, we cannot do it. What we need to do is, we will see the same example, but we will create the structural members separately. Go to structural members, select the first beam and new group, and once again second beam. Once you complete it, click OK here. Now we would like to finish this corner of the structural member. Go to trim extend, bodies to trim is this, and here you can see how it should be trimmed, but still it is not as per our requirement. Now what I will do is, I will use the other structural members. Here I will say I need angle iron, and I will say 35 into 50. Okay, and now let's go OK. Go to the trim extend. This is the body, and one more body is this. No, first body is this, second body is this. Now here how it should be trimmed. I will use once again this one, that is end meter, and I will say this is the first one, and second one is this one. Okay, this is only for meter butt trim. I will choose this one and see the example. Now this is not working with this example. Let's see the trim and extend with other model. As of now, we had understood how structural member can be inserted on a 2D or 3D sketch, and how the different options works inside structural member command. And I was saying about in this slide about creating weldment cut list. Let's see how we can create this. Apart from this, we will have a view on the structural members used to insert on 2D and 3D sketches. We had two standards. If you required user defined sketches, you can save under this under this type in the format of library features. And groups and merge or segments, if you want to attach structural member in different orientation for a profile, you can use group. And merge organs, you know that the line and the arc, if you attach structural members, both will be in same structural group. That's what we had seen previously. Apply corner treatment, we had seen to some extent. Let's see what is that. Alignment, locate profile, we had seen when we are creating this member. Let's see how we can get weldment part list. Okay, before that, now here we have the option like cut list. Right click, give update. Once you give an update, go to file, make drawing from part. Now from this we are going to create 2D sketches or 3D view, whatever you require. From here I will choose any one format, and I would like to place the isometric view. And once I place this, I should view in the shaded mode for a better understanding. And once I complete this, now the first requirement is we need the table, that is weldment cut list. Select this, click OK here. You'll be able to see the cut list. Here this text I would like to change, or size, the text is okay. Now we have changed this. Let's see the length description we have, and if required we can add additional columns. if required. Go to insert, column to the right, and here we need to insert custom properties, length, angle, unit of measure, user defined cut list, quantity, how many quantities we had used here, already quantity is there, item number is there. So these are the predefined features. Still, if you have cut list item property, from here you can choose what type of material using there. We didn't define any material there. If you define there, then that will be shown here. Okay, now you are able to understand what is the length, and moreover we're using the user defined section, so that's why we're not getting here, because this is predefined one. Once again, you can customize to get the predefined shape parameter, that is what is the section size, that also you can define here. But anyway, we understood like how many quantities we required. Let's see this 4 where it indicates. Go to insert, annotations, and I have auto balloon. Now you can see here automatically the balloon has been created, and you can see the click OK. Now you'll be able to see item number 1. This is item number 1, and here it indicates this structural member. It is having 4 quantities having a length of 6096. So total length into this divided by 4 will be the length for each structural member. This is how you can calculate the structural member required for the whole fabrication assembly. And now let's see this trim and extend in structural member design. How can we trim the structural members like C channel or I section? We have different types. Let's see how we can create end trim, end meter, but all that, let's see how we can do this. In this example, we are going to see how the structural members can be trimmed using trim and extend, and how different end condition can be given. Just have a look how this part has been created. I created this frame using first structural member command and one more structural member inserter, and extrude at the bottom. Now I need to end this corner in a different way. Go to trim and extend. Here we have different methods. I will choose first body, and second trimming body is this. You want to use either end trim or end meter, what type of butt you need. You can choose from here and click OK. So this is how you can use trim and extend. And apart from this, trim can also be used with respect to a defining face. Trim and extend. This is the body I need to trim. Here I can choose faces, and I will say up to this face, and up to this face exactly you can finish it. Okay, this is how you can trim the weldment structure using either bodies or face or datum plane. You can use any one of this. Once you trimmed it, the next job will be you need to add strength for the structural members. Let's see how we can add strength to this structural members. I click OK here. Now I will trim this one also, or I would like to end up to this. Similarly, we can do it for the other 2 legs. Now to add strength, we have command called as gusset. Select the first supporting and second supporting face. You'll be able to see a gusset is added here, and this you can position either at the mid or at the end. If you use offset, you'll be able to once again position from the midpoint. And thickness what you required, the profile type what you need. Here you cannot use user defined profile. What you get here, this is what you can fix using gusset. This is all about defining gusset. Once you complete this, definitely this bottom plate has to be welded to the structural member. How we can do this? Go to the command fillet bead. We have 3 type of fillet bead: full length, intermittent, staggered. I will use full length, first phase and second phase. Now you can see full length weld is attached. You can have add weld symbol, or if you don't require you can remove it. If you use add symbol and click OK, you will be shown with an symbol as 3, which is indicating the size of this fillet bead. Let's see one more example for applying different type of fillet bead. To understand this example, I will use 2 different bodies, and then let's see how this will work out. This is one single body, and I will extend up to here. Once again, one more base I'm going to create here. Click OK. After this, the length I will define up to here. This is for us to understand how this weld fillet bead will work. This should not be united. I'm not going to merge it. And I'll go to weldment, fillet bead. Here I will use intermittent, first phase and second phase. Now we are getting this intermittent. The size bead length is 10, okay, and pitch is 10. Now we can see it is 10 right now. I will make it as 20. Now I will be able to see the pitch distance and bead length. I'll go and say staggered. Okay, here the phase, once again I'll use this phase also to create. Okay, and when you see from the top view, you can see the arrangement of fillet bead here. I will once again increase the fillet size as 10. You can see the difference, how this intermittent is distributed. You can see it starts here, and once again this gap, and once again we have fillet, and parallelly you can see the attachment on the other side. When I go and say staggered, and here I will choose virtual edge. You will say other side, one more face. Okay, this is the face, one more face, and second face is this. Now I will choose one more time. Go to fillet bead, intermittent. First phase is this, second phase is this. We created this fillet size 6. This should be 6. This should be 12. And other side, first phase is this phase, second phase the same phase. Okay, and now let's see from the top view how this will create using, how this is created using intermittent. Intermittent, you can see both the sides I had given, but the arrangement of this fillet bead, you can see it is symmetric on both the faces. But now if I change, this should be staggered, and also once again this should be staggered. You can see the arrangement of this fillet bead. Between these two fillet bead we have one bead on this side. This is what staggered. So this is all about creating fillet bead using SolidWorks. And we are also seeing creating gussets. This is especially given to reinforce the area between two intersecting structural members with planar faces. The types can be either triangular or polygonal. End caps, definitely you know how it should be created. We can just close the open structural member using end cap. The command is available here. Where is that? End cap. Yeah, there should be an structural member which is open, which can be filled. Here to show an example I will use that, but this is not the exact application where we want to use end cap. I will go to the structural member, select this face. You will be able to create this end cap. Now the question is, where is the different models given with parameters to create this? Please refer our SolidWorks reference guide. We given 6 different activities of creating different structural assemblies, and every project is followed with specific command to complete it. So there are 6 activities covering 7 commands available in a extensive way. please go and complete to understand the features available in SolidWorks, especially with weldment. In this weldment, apart from this, you can use the weldment structured assembly, and in the assembly also once again you can use fillet beads between two components, and it's all about weldment. The next interesting topic will be surface modeling. Let us discuss in detail. Surface modeling. Surface modeling is of two types. One is creating class A surface design, and one is creating class B surface design. Class A surface, and we have class B surface design. What exactly this class A and class B will define? Both are used to create the products, but specifically if you look into class A surface, this is used to create components such as aerospace products, or I can say aerospace components and aerospace products, and it is used to create automobile components and shipbuilding designs, shipbuilding, and consumer products. Now we have a question: why we need a surface modeling? Why we cannot design all these components in solid modeling? The very simple reason is, when you execute part modeling commands, you will not be able to get the surface with tangency and curvature continuity in the whole geometry. But when you think about the car body or aerospace body, you could have noticed everywhere it will have only smoothness. Nowhere you can't find sharp corners. And that structure, if you decide to create, definitely you have to understand how the surface tools could be used to create that. And class B surface is once again creating similar type of geometries, but comparatively class B will not give you finishing how you do in class A surface, but almost both will look like same. But class B surface is of creating like free-form faces. Once again, it has smooth faces, but you cannot give the constraints how you do in class A surface. The practical examples for surface modeling, you can say the entire car body design or different components used in aerospace. Once again, what I said for class A surface. In class B surface, we can say especially components like consumer products and electronic gadgets and sports goods. We can say number of examples for class B surface modeling, but all this will not have exact finishing like how you do in class A surface. But in general, if you look into surface modeling, we require the surface should be smooth. It should have only tangential or curvature, and nowhere it should have a sharp corner. That's why we are getting into surface modeling. And creating a surface model is not with a specific rule. With respect to the data available, you can either follow with creating with the existing images. With images means you will place the image, the front view, the top view and the bottom view on the plane, and remaining you will create it. That means placing this different front view, top view and bottom view on the front, right and top plane, and based on that you will create the sketches, and that sketch will be used to add material, and finally you'll get the design. This is one. And second, using a reverse engineering process, using cloud points. Using cloud points you will design the surface model, and we can also create surface model using points and lines, and from the lines you will generate surface, this can be sketch based, or this that we call as sketch based modeling. You will create a parametric sketch, or you create a rough 3D sketches, and based on that you will create a surface model. And these are the three different ways of I'm saying this is not the only three different ways. Apart from this, you can have a number of ways of creating surface model. This is one of the three approaches in creating surface model. And when you look into surface modeling, the approach what you do in SolidWorks is so user friendly to create any type of component design. Let's see how we can create the surface modeling tool using SolidWorks. Before that, I would like to give you one more clear about surface modeling. I said about designing the car body using surface modeling, but that component is not actually surface. You know, the surface is having zero thickness, we used to say. So once again, how we are relating with that example. Car body is a sheet metal. Actually, we used to say in the practical term BIW, that is body in white, that we call as sheet metal. But creating that sheet metal in sheet metal design environment will not be the solution, because the output what we need is number of curvatures, tangency continuity in the whole design. But that cannot be achieved using sheet metal design, but that can be achieved only using surface modeling tools. So what is the requirement? Once you complete the surface model, that will be used to create core and cavity. Once you create core and cavity, and you will feed the sheet metal into that core and cavity, and it will be pressed to form the shape. This is how it is done practically. And that's why we are saying this cardboard and other car body can be designed using surface modeling tools. And that's why you can see the software like CATIA, like NX, all are familiar with automobile companies, since it is most probably used for product design, automobile and aerospace and shipbuilding. Now let's see the interesting commands available in SolidWorks for designing surface models. Surface modeling tools: extrude, revolve, swept, loft, boundary surface. Definitely you might understood the different commands what you see here. The same it works with the solid modeling. Now we are going to see creating extrude surface, revolve surface, and this deodorant bottle and shoe using this surface modeling tools. Let's see how we can create this. Now this is the sketch I had created. Now I need to add material, means I need to create a surface for this sketch, but extrusion should be normal to the plane. How we can do this? Now you understood. Now we will understand how the sketch has been created. I created 2D sketch and one more 2D sketch, and using 3D sketch I had converted this 2D sketch into convert entities. Using that command I had made one more copy on this. Now this sketch is inactive and these two are in hidden condition. Now you can see how the surface is added to this. Go to extrude surface, select the sketch and this sketch, and once again the sketch, and the direction is top plane. Now you can drag this, and when you're dragging it, once again you can see in the you can add draft to this surface. I will use draft, and here the draft angle should be 5 degrees. You can see the draft applied on this sheet. This is how you can create extrude surface. So the extrude surface can be created either parallel to the sketch or normal to the sketching plane, or you can define a direction. This is how we can use extrude surface in SolidWorks. Now let's see an example for the revolve surface command. This is the cap of a component. I had used a sketch like spline and 2 line segments, Now let's see how revolved command is used to create this. Go to a revolved surface. This is my sketch, and once again we need to define the axis. Now you can see the cap is created, that is the bottle cap is created. This is one simple example of using a revolve command to create this cap of the bottle. And when we are creating this revolve, you definitely will be knowing it. You can use the cursor, you can use angle how much you want to define as the axis of revolution. And once you created this, you can convert the sheet, because as you know this is the zero thickness. You have to use the command thickness. Select the surface thickness, I need 1 mm, and click OK. Then now you will be able to see the cap. Now there is one more question, why I need to create this shape using surface. I can create this easily using solid thin feature command, but once again why we are creating in surface, and once again we are doing thickness. The advantage what we have is, let's see the one more advantage we have. I'll show you. Now what I will say, this should be 360 degree. I need a cut on this faces which can be a stylish for this cap, which can be a stylish feature. Now I need a plane, this plane. Okay, now I will create a plane for this axis, temporary axis, datum plane. Here I need to create a datum plane. Go to insert, plane. This is my plane, and one more is this. Now we got a plane on this, referring these two references. Now this plane I will be using to create a guide path. In this guide path I need a shape to travel so that I can trim it later. And once again I'll go to reference plane, select the sketch, and this is my part. And now we will create a sketch which need to travel along this guide path. Okay, we'll make it parallel to the screen. Okay, this sketch, where is the sketching plane? Here. Go to sketch, view parallel, and now I will create the line segment. That means a profile which we need to travel here. Once again we will make one more curve passing here, and this should be exactly colliding with this. It should be exactly matching with this. It should be coincident, and this too should be tangent. That means this line segment and this line segment should be tangent. And now let's create one more line segment on this side, and that should be tangent once again. Once you create this, now my next task is to sweep this profile using surface. Go to sweep surface. This is profile, and guide path is this. Now we had created, and let's see how we can trim this. I will hide the sketches, datum planes. Go to trim surface. We'll use mutual first and second. Okay, these two surfaces. Now remove. Which one you want to remove? I want to remove okay, these two. We had two surfaces here. Which one you want to remove? Move them into multiple pieces. Okay, now what I will do, I will go to once again trim surface using standard. This is the trimming tool, and remove is, okay, trimming tool is this, and removal is this face. Now we have one more attachment inside. I will go and remove this. Remove this face once again. I will cancel this and we'll do it once again. The sketch I will extend one more time so that it can be used for trimming the surface. Trim, mutual, we can select two surfaces. One is this and second surface is this. Now which one you want to remove? one or more surface cannot be trimmed into multiple pieces. Okay, split all don't require. Now natural trim required. Keep. Not working here. Okay, now what we can do is, one thing we can do, I will go and say intersect, project, split, intersection. Now this will work out with the first one, and second thing, we got a curvature here. Now what I will do now, I will go to trimming tool is trimming tool. I will use the split line and remove this surface. I want to remove this surface, and we need to remove this inner surface. Go to trim, or I will use delete face and select this face and remove this. But we are doing number of times the same command, so it may look like it is consuming more time, but here, since the geometry we are assuming it, we are doing 2 or 3 times. But if the geometry is correct, we can do this cut in one single operation using the command sweep. We can sweep the surface and then we can trim it. Now the same feature can be made multiple copies, and you can create similar shapes on the other sides. Feature, you will use circular pattern, and here faces to pattern. This is the face. Now we cannot do it since it is trimmed one. Now it is one single body. You have to do this one at this stage, and later you can trim one by one. So this type of feature, this type of cut, if you want to do in solid modeling, it will be tough to create. And moreover, once you complete this, and if you want to be that should be a thickened surface, definitely it will not be an advisable one, since it will not follow the conditions: surface, curvature, tangency, continuity, everything. It will not follow it, and that's why we are saying this is the most preferable way for creating the. Okay, here it's in transparent show. That's why we are saying to create these type of components, you should be able to use surface tool, so that you can avoid creating with multiple commands. Instead, you can go with one single command and you can create this. Okay, now this geometry, actually we need to make it as smooth so that we can get it. I'll go and say fillet. This is the curvature where I want to make fillet, face fillet. Here 2 mm, first face and second face. Click OK. Now we have smooth surface, but still if the geometry is able to create, then we'll be able to apply the thickness. Yeah, it is able to create 0.5. Click OK. Now I can see the thickness and applied on this face. This is how we can create the components using surface model. This is one simple example. Similarly, we can create the various projects given in your reference guide: creating mobile cover, creating helmet, water bottle, mouse. All this, when you create in solid modeling, definitely you will not be able to create the cut like this, or you will not be able to create complex shape using only solid modeling tools. Now let's see one more example of using boundary surface, and later let's see how to create this deodorant bottle. I have the shoe here. I need to create this. Then it is created. Now let's see the base of the thing. It is how the sketches has been created. I will unhide all the sketches from here to here. I will unhide this. This is open, and this should be shown. This should be shown. This should be shown. Okay, this show this one, and once again this sketch I want to show. So basically I started with the first base sketch, and second there are 2 sketches, one and ellipse. These two are combined to form this sketch. Using the command, which command? From curve, project curve, we are using sketch on sketch. Using this, I selected this base sketch and this arc to get this profile. And once I completed, I had drawn this guide curves and these two guide curves. And later I'll go to boundary surface, select the first boundary. Now second boundary I need to select this boundary. I don't require all this zebra lines and different curvature. I will clear the mist faces, and now I can drag this to get exact finishing. And once you completed, you can define the direction too. First one is this. Since it is done in one single sketch, I will use selection bar to say one, open the sketch, okay, and second this one, okay, this one, okay, and the last one. Completed. Now you can choose either it should be normal or it should be tangent. If you use direction vector as normal, definitely in this area everything will be normal to the direction whatever going to define here. Will give normal to vector everywhere. The bottom profile, not here. This should be a none, this should be none, but in this point I will use normal to direction vector. Let's see here. I will go and say normal direction to vector. If I'm defining here, I will choose this top plane, and with respect to that, this surface will have the shape. Normal to profile, it is not able to create. Make none. Okay, this is how you can if it is existing with the other surface, then you can say normal to vector or normal to profile. With respect to that, you'll be able to create the surface. And when you're creating this, you have one more advantage of using trim by direction 1, and you have the influence of defining to next curve, to next sharp curve. This we had seen in detail in the part modeling. This is one example I'm showing you how to use boundary surface. Still, this command can be used to create the mirror on the car door, where you will create the whole car door, and later you want to create only the mirror on the open loop in the door. There you can say direction 1, direction 2, where you can create a sheet, and that sheet we call a surface mode, the surface, and later you can add thickness to make it as a mirror. This is one simple example of creating the shoe using boundary surface. And now let's see one more example of creating this deodorant bottle. Let's see how different command can be used for this. Now I removed all the surfaces. Let's see how we can attach surfaces for this wireframe. First, we will use this one to create a revolved sheet here. The next process, using this 4 guide curves and one path, we are going to create a swept surface. And here swept surface, we don't have sketch. This is the bottom, it is the profile which need to travel. I will show this. Now let's go to the swept. This is the bottom sketch. Click OK, and the remaining guide curves. First one we need to define, this is my path. Okay, then guide curves, let's start from 1 and then 2 and third shape, third guide curve, and fourth. We define everything here. That means we define the 4 guide curves and one path and one section here which need to travel. And once I complete this, my next aim is to trim this sheet using this line segment. Go to trim surface, trimming code tool is this line segment, and removing is this face. Click OK. So just we have completed the partial of this. I'll go and hide the unnecessary sketches, which means we don't require for the display. I'll hide the sketches in one single stretch. Go and hide sketches. Where is sketch? Sketches. And now we need to blend these two. faces, go to lofted, select the first one, that is this one, and say OK. And second sketch is this one, click OK. Now you will be able to see the surface is created. No, not. The reason is in this group we didn't say this should be closed. Now I'll select this one and also select the group, this group. I'll cancel this. Once again remove and do it using selection manager. I would like to use select group 1, 2, 3. Click OK. And second this edge, click OK. Now you can see the sheet is attached. Once it is attached, we need to say start end constraint. Here which is the start? This is the start. Okay, this is start and this is the end. This end should be tangent to the faces, and once again this end should be tangent to the faces. Okay, sorry for the interruption. Now you can see here we have removed this using surface locked. I'm sorry to interrupt. Once again I'm repeating this. Using tangency to the face, we had given this surface a tangency to this face and end constraint for with respect to this surface. Once you complete this, click OK here, and now you'll be able to see the deodorant bottle surface is created. But bottom, if you look, it is open. Now I need to close this. To close, you can go to the command called as filled or planar. Now I will use planar surface since it is a planar face, which means it is on the planar face. Select this loop and click OK here. Now the sheet is created. And still this bottom surface you can apply fillet to make it smooth. You can go to fillet 2 mm, say first surface and second surface is this, and click OK. And later you can unite all this using knit surface 1, 2, 3. Click OK here. It's saying try to form solid. Click OK. Now it's in solid. You can see in the sectional view it is in solid. And if required, once again you can say I want to shell this. Using shell command you can use shell and say it should be show preview. And now let's say about this is of 2 mm thickness, it is not about 10 mm. I will go to make the shell thickness. Now it is computing it. We'll make it as to be 2 mm and it should be 1 mm. I'll make it 1 mm and click OK. Now it is of having, let's see how the inside geometry will be. We'll go to the sectional view and you can see the inside one. If you don't require, it should be at 2 different components. Once again you can do one more thing. Okay, shell is removed. I'll go to shell 1 mm, click OK. I'll use insert. We have features, split using a datum. Okay, and cut the part. Now we have 2 different parts. Click OK here. And once again you can use these 2 different parts. You can use insert into new part, and you can use that part for creating core and cavity. Let's go and see by moving this body how it will look like inside. Move this using this triad. This is how you can create a surface model, and you can split this. So that's all about using extrude, revolve, swept, loft and boundary surface. The next interesting topics are creating planar surface, offsetting, creating radiate surface, extending the surface, and surface fill, and finally ruled surface. Let's see how we can do this in SolidWorks. Now, planar surface. Already we had seen example in closing the bottom face of a deodorant bottle. Let's see an example for closing this bottom face of this shoe. Go to surface. From here you can choose planar surface. If you want to understand from which menu we can choose all the commands, go to insert. We have surface. In SolidWorks, for surface, sheet metal, part, weldment, everything will be in the same part environment. Now you can add this toolbar by right click on this. You will be able to select this one, and accordingly the tools will be here. And once again you can customize this by using customization. Now let's see applying planar surface. I will select this curve, and if I click OK, then you can see a planar surface is attached. This is how you can attach a planar surface for it may be a surface or it may be a solid. According to the edge selection, you will be able to create a planar surface. Now the next example, let's see how can you create ruled surface. This is my sheet which I'm going to use as a cover for an electronic gadget. Now I required to create a parting surface. That parting surface can be created using ruled surface. Let's see how we can create this. Go to the command ruled surface. We have a number of types: tangent to surface, normal to surface. Number of options are there. I will first select this is my edge, and if required you can continuously select the edges, which is here tangent to this. Select this all the edges, and once you selected you can see the sheet is created. But this sheet is right now normal to the surface. Even though if you select the edge, this surface in which orientation, accordingly the sheets will be created. And you can extend the length, which is directly giving you the creation of parting surface. This can be tangent to surface or it can be normal to surface. Let's see an example for tangent to surface. Now I can select this edge, and you will be able to see the tangent to face, normal to face, taper to vector. You need to input any datum plane, which means that will be acting as a direction. And now I chosen front plane, and degree is given 8 mm. And if I enter as 45 degree, you can see the surface created on this edge, perpendicular to vector, sweep. So here if I choose multiple edges and front plane is given as direction, I will choose as the top plane. So this I will clear, and I will say it should be a top plane, not top plane, front plane. Use front plane, and you can reverse it to understand this sweep. So 30 mm will be the length of this sheet. This is how you can use ruled surface to create parting surface for any component which is used for core and cavity creation. The next example, let's see how we can use filled surface. This is the iPhone cover. Here this area is open, and we need to fill this open area. Before this, you can understand how this is created. The first initial sketch, we created this base extrude and using this sketch. And once I complete this, I created a plane exactly on this point, so that I will use a surface sweep to complete this one. In surface sweep, we used this edge as the section, and a guide curve we had drawn this. Using this we completed this iPhone cover. Once we completed, now there is one more option. That means we have one more open to close this surface. We don't want to go for any other guide curve sketches. Just go to fill surface, select the edges. When you select the edges, you can see this open closed loop will be filled automatically with the surface. And that too, the surface can be either It can be tangential or it can be curvature, that you can define from here. It should be tangent or it should be curvature. But as of now I will use contact, since the surface here I need it should be exactly contact with this edge and then this edge. And this is how you can use filled surface to create this cover. And once you complete this, as usual, you can go to knit surface and you can say this sheet and this sheet and this all should be united. And once you complete it, okay, before uniting I will say uniting should be different for this sheet, because we are going to mirror this only this sheet. So what I will do, I will go and say mirror, here mirror command, plane is this is my plane, faces to mirror 1, okay, faces to mirror this one. Now it accepts only the bodies, this body, and click OK here. Now let's go to the surface tools, knit. Now you can assemble all this into one single entity, and once you complete you can give thickness to the whole cover. I'll say 1 mm and click OK, make it as 0.25 and click OK. And now you can hide the solid bodies, you can hide the surface body to understand the solid. As of now surface is automatically hidden, or you can select this and you can hide this. This is the source, so you can leave as it is because this thicken is based on the surface. And you can apply colors and you can see how this iPhone cover is created using surface modeling tools. The next radiate surface. Let's see how this radiate surface is used to create this wing on the impeller, or I can say this we used to say a fan which is rotating at high speed, especially for cooling purpose. Let's see how we can create this wing. My first task is I had created a sketch here, and using this sketch I am going to project on the surface. There's one more sketch available here, and this is a revolve body. Go to insert, split, project. This sketch should be projected on the surface. Reverse it, click OK. Now it has been projected. We had two faces. Using this I am going to create a radiate surface. To choose the command radiate, I will go to insert, surface, radiate. The direction is I will use top plane, and the edges are, this is my edges, and this length should be of 90 and click OK here. Now you can see sheet has been created, but still this should be extending up to here. And once you complete this, we have one more sketch. Using this we can trim surface using this tool, and which should be removed, this should be removed. Now you can see we had completed this fan wing. This is how we can use radiate surface command to create surface sheets. And finally we are going to see offset surface. Now let's see how many commands we have covered. Planar, offset, radiate, extending we had to see. Let's complete this offset surface. Offset surface, whatever the surface, it may be a solid or it may be a surface, you can go to command offset and select the sheet. The distance what you need you can enter here, and that will be offsetted to a distance of 10 mm. And once you completed, you can extend if you want to extend the edges for other geometry creation. Let's see an example for extending the surface. Go to extend. In extends we have distance up to point up to surface. I'll use distance same as surface. Now if I choose this edge, and you can see this is what same as edge. If I use linear, you can see it will be moving in the linear direction, and the distance can be given using the distance for this, or you can input using up to point. I can say up to this point I want to extend exactly, or up to this surface I want to extend. But here As you know, this is not a planar surface. Exactly, we cannot choose for up to surface. This is how you can use extend surface to extend the edges as simple as possible. It's all about using surface tools. The next we are going to see the other commands used in surface modeling. Let's see each command in detail. Now we will see how we can trim surfaces using trim tool. This is the wireframe. Now we are going to design the helmet using this wireframe. First one, loft. Guide curves I need to define. Okay, this cannot be done with loft. We need to go swept. This is the profile. Okay. No. One thing I need to check here. Okay, this can be done with the loft, not with surface. Loft. This is the guide curves we have here. Okay. Now this is the first section, and second. Okay, not this here. This is the first profile, and guide curves are first one, and second. This is the second guide curve, and third guide curve, and fourth. Once I complete this, I will say this should be a closed loft, and here we need to see the preview, but the preview is not showing here. I'll say global, not able to display. I'll cancel this. Once again I'll go and say surface, lofted surface profiles, or these are my profile 1 and 2, 3, and this is my 4th. And once I do this, I'll say close loft, but this should be following a guide. So once I complete this, now we are in the position of trimming the unnecessary surfaces. Trim surface. Before that, what I will do, okay, now let's see trim. This is the sketch. Remove this one, and inside right click. Now we removed. The next condition is I'll go to project this sketch on this face, reverse, and using this once again we'll go and trim this one using this inside surface. And to fill this, I'll go to fill surface. Using fill, you can fill this. And once you complete the same thing, you can go to knit command and you can knit as a one single sheet. And now I don't require the sketches. I'll go and say hide sketches. Now you are able to see the helmet design. This is how you can create helmet using surface modeling tool. The next command is creating mid surface. Mid surface is most probably used in analysis. When you want to create the mesh on a thin feature, it is time consuming job to create a mesh on thin feature. Instead, you might create the same mesh on a thin surface, representing that surface as a thin feature. In representing the whole thin feature as a one single surface, we need to have a tool where that surface will be created exactly as a mid surface between two center surfaces. That means now this is a revolve body. This revolve body, if I use for meshing, for validation, it will take long time to process because it's a thin surface. Since a thin surface, we can do using the command mid surface, and later you can avoid the steps involved in this. Go to surface, mid surface, you can select the faces. I'll use find faces, and once again this one, okay, it has used. Now position is 50%, click OK here. Now what I will do, I will go and hide the solid. Now you can see the sheet. So this will give you an easy way of creating the surface, and this surface now you can use for meshing, which will avoid the time consumed in creating the mesh for the whole thin feature. So here the objective is mid surface will be most probably used 70 to 80% for creating mid surface required for the thin features. Now let us look into the next command, replace face. Replace face, once again an advanced command. In this example, the surface of this top geometry of this part should end like this twisted face. When I do with other command, it will take a long time because we need to say guide, section. Using replace, you can define which face you need to change. This is my target, this is my surface I need to change, and target is this face. Click OK here and hide this surface. Now you can see the surface which was planar, now it is having the twisted face. This is how we can use replace face. The next, delete face. Delete face is especially used to remove the holes, slots from an import body. Now let's see this example in an imported body. This is a sheet metal components where we need to move this entire slot from one location to other location, or I need to remove this hole. Go to delete face, and if I select this faces, not this face, I will use delete and I will say this all the faces I want to delete. Click OK. Now you can see the face is deleted. Once again, if you say delete and fill, you can see that face will be filled, deleted, and it will be removed. This is once again, it is not applicable for this model, but if you import any body which is not created in SolidWorks, you can do patchwork using delete face. Now let's see the other example, move face command. Surface, where is the command move face? Mid surface. Okay, this command will be available in the face. We have move face. Select this and which surface, these are the faces I want to move, not this one. Now you can see we have translate. You can use translate and you can position up to the required area where you want to relocate this. I want the direction. This is my direction. Okay, once again I will do it. This is the surface I want to, not this one. To remove this, I will say these are the surfaces I want to move, and we can use this triad and to say the distance, up to which distance you want to move this. Now you can see we are moving this, and offset, and we'll say the distance how much you want to move this. Okay, here I will say also this faces. Use translate. Now I will move this and I'll keep it here and click OK. Now the same feature is moved from one location to other location. Similarly, you can move the faces, you can offset, you can translate. Once again, you'll go to insert, face, move. You can select the faces, which face you want to offset. I'll select this faces, and it should be offset in which direction. Translate, I want to translate in this vertical direction. You can move up to some extent, not exactly to the top, but with proper parameters, if you do it, you'll be able to get the shape. But here I'm just showing you the example. And you can also use rotate to rotate to some angle. You can use this to say I would like to rotate on this one, this face. Once again I will remove this. We'll say delete this one, delete, insert, face, move, select this faces, and also this. Okay, it is selected. Now I will use rotate. Can rotate, you can position this exactly where I required, and now you can use rotate. Okay, but here as it is not exactly matching with the parameters whatever we enter, We can enter the degrees if we give an edge, but here we are assuming it. But once you do with your own model, you will be able to do all these operations. This is about offset. Sorry, move with offset and translate. The next command is untrim. Let's see how we can do untrim. Untrim, if you look into this design, and if I'm making an trim using a sheet, okay, we'll go up to this surface, not this one, up to this surface. This I will trim with a different option, like I'll create one more sketch from this. I will unhide this. Okay, it is in unhide position. Okay, show this now. This should be shown. I will use extrude, and I will say this sketch is used for extruding. It should be symmetrically distributed. Once you complete this, I will go and say trim or standard trim this one, and to remove these faces. Now here what I will do, I will say trim. This is the sheet I need to, this is the trimming tool, and remove this faces. Okay, once again I will go to the tool and I will say remove these faces also. And for our understanding, I will hide this. Now we have this sheet, still we can remove it. I'm saying this also, this should be removed. Okay, it is not removed actually. Go to this, remove this surface, this and this. Okay, and now we can go to untrim surface. This is the sheet. You can see here, when I select this, it will be showing the untrimmed area. You can increase the percentage to input how much you want to get this untrimmed surface on this face. Click OK. Now we are assuming it, but still you can do it better. But I will show this once again in another example. Here we will see joining the faces and giving thickness. This is the sheet. This is created in this way. First one, start with the revolve, and next we created a sweep feature here, and using trim we are trimmed this. You can see here we are using mutual trim, two surfaces selected and removing this unwanted portion. And once we complete it, we are going to mirror this feature, mirror, and based on this front plane, mirror this body. And these are two different bodies. Use knit and say these two should be united, and click OK. Once we complete this, we can go and use thicken, select this face, make it as 0.25. Now you can see a thin bottless creator, exactly how it looks in real time. This is how you can use surfaces to create consumer products like bottle. And the next example we should understand once again untrim. I will show with a different example. Let us understand the untrim surface using this sheet. I had trimmed it. Now I'm going to use untrim. Select this edges. You can see the difference here. If I increase this, accordingly you can get the sheet. And here you can see all edges, internal edges, external edges. If you have any holes or any slots on this face, accordingly you will be able to untrim the edges. This is what all about untrim. Let's see one more example using the other model. We'll go and do one more sketch on this face. Let's see how this is extended. One thing is, I'll make one more rectangle here, and I will use once again trim to understand this. Remove the faces. This is the faces. Now let's go and say untrim this face. Now if you use internal edges, you can see this is what internal edges. If I use external, only the external edges will be done, and if you use all edges, everything will be selected for untrim. This is what all about untrim surface. And that's all about surface modeling in SolidWorks. And using this surface modeling tools, definitely you will be able to design any type of model with respect to class A or with respect to class B. Anyhow, we have advanced modeling tools like flex, freeform, deform, which is once again helpful in modifying both solid and sheet metal design. Means solid and surface modeling, not sheet metal. Using this advanced command, you can do any consumer product. Using flex, you can do a twist, bend for both solid and also for surface modeling. That's all about doing surface modeling in SolidWorks. The next topic will be sheet metal design. Let's see sheet metal design. The next interesting topic, sheet metal components. In this slide you can see the different assemblies where sheet metal will be playing the major role. If you look this component and if you look this unit, everything is made of sheet metal component, and this is an assembly where you can see the complete part is within and cover, which is once again a sheet metal. And this is an CPU where everyone will be using in their day-to-day life. Everywhere we can see the use of sheet metal design. So what actually the engineer will need from this sheet metal design, and what is the limitation when you do the sheet metal design in manual drawing? The first foremost thing you have to think about when you are designing a sheet metal, that what is the length of the metal or sheet I need to cut. This is one. And second, we need to understand how this folded and unfolded view will be shown, because based on the unfolded view only you will be able to cut the template. Then using the template we'll go for mass production. And sheet metal design using standards. When you think about big companies or when you think about any factory which is involved in sheet metal design, definitely there will be a set of table where according to the material and according to the thickness of the plate, bend angle and then bend radius, everything will be defined. So here once again the bend design is based on the standard tables. So designing based on this will be tough when you go with normal part design or with manual work. So we need a software to satisfy all the needs. But there is one more thing, we should understand how we can input K factor or bend allowance for the calculation of sheet metal design, that is the unfolded view length, and that is what the most essential part of sheet metal design. Once again, I'll repeat the same. The reason why we need a sheet metal design tool is to understand the fold unfolded view, creating the sheet metal based on the standard tables materials, inputting the value like K factor and bend allowance, and finally getting this flat pattern, that is unfolded view in orthographic view, or getting in the format of DX of DWG, where you can use it once again for the production purpose. This is what the main advantage in sheet metal design. Now let us understand what is bend allowance and K factor, how the formula is derived, and where this formula is used in SolidWorks to create bend allowance and K factor in a sheet. To find out K, you need to check the ratio between small t and the capital T. Small t is the distance from inside face to the neutral sheet. If you take any sheet, if you fold or unfold, you can see a contraction in the outside surface and expansion the inside surface. But there will be a sheet here you can see in green color, which we call as neutral sheet or axis, which will not have any expansion or contraction. So that distance will be given in the format of T. that is small t, which is mentioned in terms of ratio. For soft brass and soft copper 0.35, hard copper brass and steel aluminum 0.41, and bronze 0.45. In this way you will have the input for the neutral sheet axis. And bend allowance, you can see here the circumference of this arc is bend allowance, and radius is the bend radius. Angle, which is measured in radians, will be given as input. Based on this formula you will find out K, or you will enter the K value to design sheet metal design in SolidWorks. And these are the common, or I can say these are the sheet metal design tools used in SolidWorks to design sheet metal components. Let's see one by one each command in detail, but before that we should understand what is allowance, that is bend allowance, and bend reduction, K factor, and relief and corner treatment. Please refer your reference guide introduction, where you can see the brief discussion how the formula is derived and how and where you have to input to create the sheet. Now let us start with the basic one, creating base flange.